Hello and welcome to lesson 28, which is on total internal reflection and prisms. This is basically the two special case scenarios when you have refraction occurring in a material. If you remember from the last lesson, we talked about how there was the possibility of internal reflection, and when you played with the applet, sometimes that would occur. Let's just double back and take a quick look at that. All right, this is the applet from the previous lesson on refraction, and as you can see here, we've got the same medium on both sides, diamonds and diamonds. Now, internal reflection occurs when it goes from a very dense material to a less dense material. So as I change the outside material to something less dense, first glass, water, then air, we see that the angle, of course, increases as the angle of refraction, indicating, of course, a less dense material. As I rotate it towards 90 degrees, it eventually flickers and gives that total reflection symbol, like you've done something wrong. But really what's going on here is you've reached what's called the critical angle. So once you reach 90 degrees on the exterior material that is less dense, it's kind of like skimming across the surface. This critical angle represents the point where you can't actually refract anymore because you're going to bounce into the new or the original material. And so what you end up having at this point is internal reflection. So anything less than 90 degrees, you get refraction. And of course, because it's in a less dense material, it's going to be a greater angle. And then once you pass that critical angle at 90 degrees, you get internal reflection. And so of course the angle of incidence is equal to the angle of reflection, just like regular reflection. Let's move on to prisms. Now before we go on to prisms, let's take a little bit of a sidetrack here and relax for a second or two. Oh wait, this is a prism. Funny. Ha ha. We can see here, of course, if you recognize the music and you recognize the picture, this is Pink Floyd's album, The Dark Side of the Moon. And it's an excellent example of a prism. In this example, we can see how light hits the prism, starts to refract as it bends in the more dense medium, and then refracts again as it exits out of the prism. The interesting thing about when it refracts out of the prism is we see the rainbow, Roy G. Biv. The colors of the rainbow separated with red at the top and purple at the bottom, or violet. Let's just stop the music here. I know. Now, as mentioned before, this album cover is an excellent example of explaining refraction of light as it goes through a prism, then refracting again, coming out in the colors of the rainbow. This process, or this change or interaction, is known as dispersion of light. If we go back to the notes and kind of pan down through the discussion of internal reflection, which we've already covered, we'll eventually get down to prisms. Now, while I could go into a deeper explanation of what really happens in a prism, I can just keep it pretty simple and straightforward here. While it's white light that enters the prism, white light isn't just one wave. It's actually a combination of waves that we know as like the rainbow. Each of these colors of the rainbow has something that's unique, which is their wavelength. And because their wavelengths are slightly different, they refract or behave slightly different as they travel through the prism. Simply put, red light has a longer wavelength, and so it ends up refracting less, and violet, having a shorter wavelength, refracts more. You get that dispersion as a result of the variation in their refraction. Newton kind of played around with this a bit more, and he kind of figured out something very interesting. That prisms really like Pink Floyd. No, really, it's not that, but as you see here, when the light disperses, green light kicks it up a notch. It actually has nothing to do with it. What we see is that if you put a second prism out, the light that's been dispersed will actually recombine back into white light. This is just kind of cooler looking. Now back at the notes, we can see that Newton called this stuff, of course, dispersion as the breaking up of white light, and then recomposition, the recombining of this light. Now, I hope you enjoyed today's lecture on dispersion of light, prisms, and total internal reflection. Well, that's it. We will see you in the next lesson where we talk about curved refraction, or basically lenses. Until then, see you later.